Okay, we are in progress. Good evening, everybody. We are looking at software development life cycle and DevOps. The software development life cycle is where DevOps stems up from and is built from. So we have to start from the foundation of what DevOps really is, because we're all gathered here for DevOps, of course. Okay, so really quickly, what we will be looking at today, we will start by explaining and understanding what SDLC is, and then we will look at various types of SDLC that have been used and that are in use by various teams and projects over the years until now. We will also look at the traditional SDLC. We will look at the problems with that and why innovation had to move away from the traditional SDLC that was in use to bring up something that is more useful to the business requirements of most customers of our time. And then we will introduce what DevOps is and how it relates to SDLC, software development lifecycle. We will look at the benefits that DevOps has brought to the lifecycle of products and software. Then we will go over a little bit of the DevOps culture, what DevOps culture is, because DevOps is mainly culture, set of processes, rules of how to create software and how teams interact. We will look at the DevOps culture, then we will look at DevOps lifecycle. Then we will look at various DevOps practices in theory. And then we'll go into the DevOps roadmap, which will basically be the steps and the various things you need to learn in order to perform efficiently as a DevOps engineer, that I know who you are and you are getting better at being. Okay. So what is SDLC? When we talk of SDLC, the software development lifecycle, we are looking at the framework, we're looking at frameworks, we're looking at patterns, we're looking at methodology and methods by which quality softwares are designed, built, tested, operated, maintained throughout the entire lifecycle. And the lifecycle of a product is from when the concept is presented, from when the thought is brought up, when a problem is identified in a market and a solution is proposed to solve that problem, from that point, which is the ideation, up till the point where the software has reached what we call end of life. That is when the software is closed up, shut down, or is transitioned into a new software that will now be in use. So from the conception to the end of life, that entire process that the software goes through is what we know as the software development lifecycle. And in order to be cost effective and in order to meet the exact, hello. Go ahead. Is there a question? Okay. In order to be cost effective and in order to meet the exact requirements of your cost. Okay. And in order to meet the exact requirements of your customer, you have to plan out this phase as properly as possible to meet your use case, depending on your product. So SDLC helps us to not just dive into writing code without planning first. So a software development lifecycle helps us to plan out our entire project in order to meet cost requirements, user requirements, technical requirements of the product that we are trying to build. Okay, so the types of SDLC that we've seen in the development space include the waterfall method, the waterfall model, which is also known as the traditional software development lifecycle, because it is what was the first software development lifecycle presented, the waterfall method. Then we have the iterative method. We have the agile development lifecycle, which includes a lot of other processes and methods of development lifecycle, like Scrum. Scrum is agile. We have Kanban. We have DevOps itself, in a sense, is also related and to the Agile software development lifecycle. We have the rapid application development, we have the V model, the spiral SDLC, DevOps, and the incremental method. Most of these might not be necessary for you to know right now. But depending on what team you're working with, you can encounter various types of SDLC. If you're working on a project that doesn't require a lot of changing requirements as you go on, you'll see more of what are for being used. But if you're in a kind of project where if there is frequent business requirements and changes, like most products are, users can come with a particular requirement, and as the market changes, they need new requirements and new features, and you have to be iterative in the way you handle user requirements. So you have more of agile software development methods in your product building. Did we all get that? Latifa, are you still with me? Thank you, Latifa.
Yes, I am.
Okay, so moving on, let's look at the traditional SDLC. What's the life cycle, the software development life cycle that most products were using before the advent of anything agile or DevOps. So we had more rigid processes, more rigid steps to the development, and it was more logical and sequential, right? From one stage to the other, and there's no iteration, there's no going back to the last stage to do one thing or the other. When you finish with one stage, you can move on to the next, and you must finish with one stage before you move to the next one. For instance, your requirement analysis, you want to build a house. You come from the requirement analysis stage. Let's say your house is your software, for instance. When you get into your requirements analysis, you're talking about what kind of house you need, a duplex, a bungalow, what kind of person will be living in the house. You do your technical requirements, right? What kind of cement will you use? What kind of rods, metals would you use to do your reinforcements and all of that? Then the non-technical requirements, who will be living in the house, what kind of businesses will be going on in this building, which kind of people will be coming into this, those kind of things. Technical requirements, non-technical requirements, business analysis, all of that is what you have in your requirements analysis stage. When that is done, it is closed up. We know what we are doing, well documented. We are moving into the next stage of system design. And then we'll call some of our friends from the UI UX team, also from KodeCamp, of course, to come and help us with designing what kind of software we're trying to build. We go through the designing stage. When that is done, all the documentations that is, and wireframes and pictures, I guess, is gotten from that. Then we move on to the next stage of implementation and building and all of that. So that is what the waterfall would usually look like. One stage after the other, one thing done after the other. When it is done, we move on to the next one and to the next one after the other. Now, thinking about this immediately and bringing it into what most teams work with today, the kind of products we have today, you can see that immediately this might not work for most products we have, because you will need to go back and forth between various stages of building and testing, of deployments, of user analysis, all through the life cycle of a product, say maybe your fintech application. Policies can change today, in Nigeria especially. When those policies change and you see that, okay, what we knew before is not what is obtainable now, you have to go back to analysis while the product has already been built. That can't work in waterfall method. So already there's a problem with waterfall method, and it can't function for most products today. But it was quite all right, say 10 years ago, right? So innovation is the name of the game when you come to DevOps. So some problems with waterfall method. we see that software development processes were slow and rigid. They weren't flexible for changes, to accept changes in the markets or in the business requirements or even in the technology space. They were more rigid, they were slower, they required more documentations, they stuck to the rules, stuck to the plan, and were very rigid in that sense and slow in bringing out a final product. Whereas you can work on a product today and get an MVP, perhaps in 6 months. Drop in the chat what MVP is for those of you that know. You get an MVP in perhaps 6 months. You see that with a waterfall method, you're looking at something close to 9 months, a year, or even more. There was lack of proper communications. Are we here? I want to see who knows what MVP is.
Most valuable player.
My guy, thank you. What did you say? Okay, thank you. I think some of us know what it is. All right. All right, that is great. That's wonderful. So you see that there's lack of communication between teams. The business and solutions delivery guys, the product managers, will have their own conversations with the
Oh boy, give my smoke now.
business users in the requirements analysis stage, right? When they are done with that, they pass on the documentation on whatever they've done to the people in the system design stage, right? The collaboration that is needed today, the communication, the teamwork is not usually there in this waterfall method. So that is another problem that was discovered with the waterfall method. Lack of automation. Okay, let's try to mute our mics when we're not speaking to the group. So lack of automation. Automation is something that is really important in operations and development today. So that was lacking in the traditional waterfall software development lifecycle methodology. And like I said, synchronization between teams, synchronization between environments, that is, applications running in one environment may not run in another environment, right? Say I develop something on my computer now. Say I work with a Windows operating system. I develop something here. I pass it on to the next developer who works with an Android platform or Linux platform. There might be some issues that he might experience that I didn't see in my own, right? Because of the change of environment. So that is something, those are some things that we were seeing there with the development team being separate from the operations team, being separate from the, business team, right? So there was need for a change. There was need for a new approach to development and product management and product delivery, right? Enter DevOps. So DevOps, what is DevOps really? DevOps in itself involves practices. It involves strategies, processes that help to combine, bring together teams and activities from the development teams and the operation teams in order to create a better and more effective application development, delivery, and management process. What does that mean? Okay, so when you're building a product, you would usually have your development team and your operations team. Your development team would be more concerned with building the product, writing the code, testing the code, right? When it's written and packaged, it is moved over to the operations team. The operations team include people like that are in the technical team, but not in development. We see people like the infrastructure engineers. We see people like system engineers, security, cybersecurity analysts. You have quality assurance, people like that, they're not actually building the product, but they are operating it, they are running it, they're helping in the operations and delivery of that product through the product's working stage. Through the product's working stage, while it is live and deployed, or before that, right? So in the past or in the present, in some teams today, yes, some teams actually work today where the development team is separate, both in working and in both in the way they work and in the way they react to issues, completely separate in their duties. What DevOps tries to do is to bring activities from these two teams together. So you have somebody in DevOps that is able to understand the code, and even the DevOps tools, understand the code, work with the development people, and also operate the code where it is running. So instead of having a system engineer who sits down and configures your servers and waits for the developer to finish his coding, and then he does the deployment. And if there's any issue, he throws it back to developers and says, hey, we have problems, fix your code. You have somebody that can work with the developers, right, through their development process, automate testing, automate deployment, and solve issues. So that's the idea behind DevOps, right? So when working with DevOps, you have a lot of tools that you use. I hope this is not an intimidating picture to anyone.
It is.
Let it not be too intimidating. There is a number of tools you need to learn, but for each tool, there are concepts behind them, right? So the concepts help you to understand the tool, so that whatever team you're thrown into and whatever tool that they are using, you can understand it and with time pick it up. So it is it's a journey of continuous learning. Can I say that? So the DevOps culture, the DevOps process include planning, building, the planning stage, the building stage, continuous integration, deployment, operations, continuous feedback. And this is different from what you see in the waterfall. Whereas the waterfall is one step after the other, you see that we have a loop here where everything is happening at the same time and flowing into each other. While you're planning, you're building, you're continuously integrating what you're building in what is already running, what's already deployed. Changes come, you build the change, you build the new features or the fix or what you have, and to integrate it into what is already deployed, right? In a way that you don't break or what is already deployed. How do you know you wouldn't break it? You go into the operation stage, which include monitoring tools. Look at what is running, how it is running. If everything is working properly, if there are issues, you can catch them before your users even see them. And continuous feedback into what is happening. Are we running well? Is there any problem? Are there things we need to fix? There are things we need to fix. Okay, we go back into planning again, building. And this is the entire life cycle of the product until, if need be, it phases out. I hope you can see some things that you can pick up from here, some important things you need to learn. You look at the planning phase, you see tools like, you see product management tools. You see Google Drive, Google Docs, you see Asana for product management. There's Lucid Charts and Draw.io for your system design. Going into the building phase, you work with Git, you see GitHub, you see Docker, NPM for those of us that have friends in the Node.js and React world. You have your Kubernetes. Moving on to continuous integration, you have your CI tools, Jenkins, Circle CI. So all these tools have the same underlying concepts, but they implement them in their own different way. And depending on your use case, you can work with any of these tools, right? Okay. So let's look at some of the benefits of DevOps, right? Some of the things that DevOps improved in how we deliver software to our users. From the waterfall method to the DevOps method, you see that you're able to bring out and deliver a working software to users as quickly as possible. In the waterfall method, every stage has to be completed, documented, and well outlined before you move on to the next stage. So before users actually see the products that they even wanted in at the start of the process, a lot of things might have even changed in the market. But what DevOps, what Agile tries to do is to, as quickly as possible, put a working software in the hands of the customers. By so doing, you can already get a feel of whether this product is meeting the requirements or not, as quickly as possible. So while you're still building some features, you already have the main features out in the hands of customers, and you're already receiving feedback as to whether this is solving their problem, what can be improved, whether what you even have in the pipeline is what is needed at this time, right? So speed is something very important. That's why I put it at number one. Speed is something very important that DevOps brought along with it. Collaboration and communication between the developers and the operations teams. You see that developers have a better understanding of how their product is even running on whatever infrastructure platform that is being deployed to. These days, you see that developers as well as administrators work with the same set of tools, right? Developers will need to have some form of understanding of the cloud. DevOps people will need to have some understanding of the code that the developers are using, right? Because how are you deploying a Python code or a Node.js code if you don't know that you need to use NPM as your package manager, right? So you need some understanding of, you need a good understanding of programming while you're working in your DevOps field. And the developers need some form of understanding of the infrastructure that they are building for and they're building to deploy to, right? So you see there's a lot of collaboration, communication between the dev team, between the operation teams. There's shared responsibility. As the developer is writing his code, he needs to be putting in as much security features as needed, right? He needs to be implementing authentication when he needs to be implementing working with the mindset of least privilege where he needs to be working with that, instead of just writing something as the way he likes and throwing it over to the security team and say, okay, make sure that nobody hacks this software, right? There needs to be collaboration and a shared responsibility between the operation, because the security team is an operations team, right? These are operations guys. They need to tell developers, okay, these are the kind of vulnerabilities that we are seeing. This is how you can fix it from the code. There are tools these days that are vulnerability assessment tools, right? And whereas maybe in the past, vulnerability assessment tools are just looking at assessing the security vulnerabilities of products that are live and running, you have some vulnerability assessment tools that are at the building parts that programmers use while they are building their code to know if this code is meeting the security requirements, is meeting the security policies that have been set from the security team as they are still building, as they are still writing the code. So this collaboration and this shared responsibility between operations teams and development teams is something that the DevOps mindset brought along with it. Please remember, DevOps in itself is a culture, it's a mindset, it's a set of processes, right, of how to do things in a team. Because you can get into a team and they'll tell you you're a DevOps engineer. They'll tell you we work with DevOps here. And by the time you start working, you see that this is not DevOps at all, because the mindset and the culture is not being implemented. I just want to put this in there because I keep saying DevOps. It's not a job. It's a mindset, it's a set of processes that you follow while you're working. Does that make sense? Does it make sense? Okay.
It does.
Okay.
Yes,
Okay.
yes, it does.
Okay, thank you. So rapid delivery. Now, this is what I was explaining earlier.
Sorry, sir.
See that? Okay. Hello. You see that with DevOps, you are able to deliver working software. You're able to deliver changes. You're able to deliver fixes. You're able to deliver updates as quickly as possible. When there is an issue, perhaps a problem occurs in a product, or a new feature is needed by users, right? You're able to get this feature out to users as quickly as possible, test it, know if it meets their requirements, make the changes you need, and deliver it to them as quickly as possible. So DevOps is characterized by, there's something in DevOps called continuous integration and continuous delivery. This is an automated process, right, by which changes are continuously integrated and deployed into the working solution rapidly and as quickly as possible. Okay. So when you talk of DevOps again, it also has the advantage of scale with your infrastructure. Now, what scale means is how large your product is, and how your product reacts and manages new and growing traffic, new and growing users, right? If you're working with something like, I like going back to the traditional SDLC so that we can compare these two and understand what DevOps, the advantages that DevOps is bringing. If you're working with traditional development lifecycle, in your requirement stage, you might plan for the capacity of the users that you can handle, right? So you say, okay, we are going to have this amount of users, and these are the kind of requirements for the server that we need. And you buy some very efficient server at the time. And what can happen is that you might either have underutilization of those servers that you've purchased, or overutilization, in the sense that you might have less users than you and traffic than you planned for, but you've already bought your servers and you have to use them, right? Or you can have more than you even expected. And how do you handle them? So DevOps introduces with automation, it introduces the ability to manage your scale, either scale out, scaling, depending on the kind of users you're handling. And that's part of what DevOps bring in with automation. You can automation and on-demand resources with the use of cloud technology and cloud tools. You can provision more servers when you need them automatically, and reduce your resources when you don't need them automatically as well. Reliability. With the use of monitoring tools, operating tools, continuous feedback, you can in real time see how your application is performing and how it is delivering to users. If there are problems coming up, you can see them and fix them before they begin to affect a lot of your users. So you can quickly solve issues faster. And this from the reputation side of things, from the user side, you see that you are able to more quickly respond to user issues, fix failures, and your users trust you more, right? They can rely on your products more. They are more sure of your availability, the availability of the products, and know that this product, if it's down ever, with time it will be back up. That's if it ever goes down and affects the users. We have had instances where Facebook has gone down. People are not able to use Instagram. They're not able to use WhatsApp or things like that. And these things happen once in a while. And the teams are able to respond to these issues quickly. And after they respond to these issues, you see that you have more trust in the software. You have more trust in the product to know that these people are competent people, rather than a site being down for God knows how long. If you go to, well, let me not name any sites, but you see that some sites could just go down for how long, and you go to the site and you see this site is currently under maintenance. Please check back later. With that, your trust and your reliability on that software is diminishing, So these are some of the problems that DevOps tries to solve in its culture and its practice. Improved MTTR, that is mean time to resolution. How fast can you respond to an issue? How fast can you solve a problem? When an incident happens, how quickly are you able to resolve that and get the system back up running? This is DevOps tries to reduce the mean time to your resolution on issues by various means. You have your monitoring tools that help you quickly identify problems, even before your users. You have tools like chaos engineering that helps you to.
Yeah, example.
Hello, is that a question?
Okay, it's fine. Just an example of the monitoring tools. You just mentioned one now.
Okay, of course. Monitoring tools, you have things like Grafana, you have things like New Relic, you have Nagios, you have Elasticsearch. What was that? No, it's fine. I would like to hear what you said.
Prometheus also. Prometheus, are we?
Exactly. Prometheus.
Prometheus also.
Prometheus, yes. That's also part of a stack in a monitoring tool. Prometheus helps you to get metrics from various servers. You can have it on standalone servers, or you can have it in your Kubernetes environment. So it helps you get that, and that's now visualized using Grafana. So things like that, Grafana, Kibana, and Elasticsearch. Those are your monitoring tools that you can use for both monitoring metrics. You also have login tools and login solutions as well for you to be able to get application logs from your software to see what is happening in the software, not just on the infrastructure. So you can have monitoring both on the infrastructure level, right, with metrics. You have on the application level with your login. You have on the request level with your observability tools, the distributed tracing, open telemetry, and things like that. So when you have that kind of stack running in your infrastructure and your environment, you're able to have visibility and observability into what is going on in your product. With that, you can solve issues before users start knowing that, okay, there's an issue here. Sometimes you can see that, okay, there's an issue, my bank is not sending it's not handling transfers well, right? And it's happening to only you, and somebody else is able to send transfer with that same bank. It could be that there are some things that are tested on a particular subset of customers before releasing to all the customers. These are some processes that you use to ensure reliability in your software. Hopefully we'll get into that through the length of the course. There are a lot of things that we will touch on over the next couple of months. Thank you so much. Who brought that up? Who was that? Thank you for that. Nuse.
Excuse me.
Hello.
Excuse me. Yeah,
Yes.
I have a question. What's the difference between Agile methodology and DevOps? Because it seems like they have a lot of similarities.
Okay, so with the Agile methodology, there are a lot of within it, a lot of guidelines, right? That guide how you work while you're in an Agile team, while you're in an Agile system. And inside Agile, there are various other methodologies that you work with. There's the Lean methodology. There's Scrum. There is Kanban, right? Now, all these methodologies, most of them work with DevOps processes. So to be agile most of the time, you need to work with I believe most of the time you need to work with a DevOps mindset, right? So DevOps is kind of related, if not part of Agile. Okay, Toluwani.
Yes, good evening, everyone. Yes,
Good
I just
evening.
wanted to see if I could maybe answer the question a bit.
What was that? I didn't get you.
Yes, I just wanted to see if I could answer the question that was asked, like the difference
Okay, of course.
between.
Go ahead. Who asked the question?
It was me.
Okay.
Okay, so what I understand when you say agile, right? It involves the necessary steps towards ensuring a software is developed, is completed in a very, very fast way, right? So that it can get feedback as quickly as possible. Now, for that, you can now implement the DevOps mindset. So usually, Agile is relating to building the code itself, building the software itself, right? So you can now implement DevOps in it to ensure that, okay, there's assurance and also there's time, the time for it to go from ideation stage to production is minimized. I don't know if that helps or if you understand it that way.
Interesting. Thank
Yeah.
you.
Thank you for that, Toluwani.
Okay.
Okachukwu, you got it?
Yes, I did.
Yeah. Okay. Wonderful. Thank you. Thank you for the interactions. Okay. You can lower your hand, Toluwani. Is there something else? Yeah, okay. Let me just. All right. So
Sorry,
the
I didn't know,
DevOps.
sorry.
Yes, that's fine. So, like I said, DevOps is I've touched on this.
Sorry,
DevOps
can I
is
say something? So I was looking for an emoji for me to raise my hand. So I want to ask, my name is Temitope, sorry to interrupt you. My name is Temitope. My question is, what is the interrelationship between a QA engineer and a DevOps? And again, a DevOps also be a QA engineer, like DevOps QA? Like, I just want to know.
okay. Temitope, that is a very interesting question, right? I would like to treat it at the end of this presentation, right? It's a very interesting question, and I'll touch on it. I'll come to it.
Okay.
There's a way the QA engineer works with the DevOps engineer, right? And I'll come to that. So after when I'm done, I'll ask for questions and just bring that up and we'll talk about it.
Okay, thank
There might
you.
be some other people that have some insight into that as well. So we will discuss that. Thank you for that. Okay. So the DevOps culture, this involves the practices and the mindset that is followed when working with DevOps, when working in a team that is implementing DevOps, right? It includes things like automation, breaking down of silos between teams, collaboration, automated deployment, automated testing, automated delivery. So it describes the culture that you work with when you're working in DevOps. Like I said, DevOps is a mindset, it's a culture, and there are engineers that are equipped to implement this culture in a team, which are the DevOps engineers. But DevOps in itself is a culture that is used when working in a team to improve the delivery and development of products. So when you talk of the DevOps life cycle, this includes the various phases in DevOps. Somebody wrote on the screen. Okay, this includes the various phases in delivering a product in a DevOps that are gone through. The picture I showed you, that loop. Now, we are going to talk about the different phases, different steps in the loop in the DevOps life cycle. I don't know if I can go back. In the DevOps life cycle, we have the planning. When in the developments, there are 8 phases. We have 4 that you can refer to as the development phases, and then we have the operating phases. You have the planning phase that includes mostly getting in touch with your customers, knowing what their pain points are, how you can deliver on these solutions to them, creating tasks, and goals that you need to meet, breaking down this task into smaller bits of problems. Like anybody from a product management background will understand when you talk about as a user, I want to, those small breaking down tasks into that. As a user, I want to be able to make a transfer. As a user, I want to be able to see my current account balance, right? Those smaller tasks that make up the entire project, those planning, you break it down into those smaller tasks. And you take those smaller tasks and give it to the developers and they start writing codes on that. As a user, I want to know that my banking app is secure. They begin to build authentication and authorization processes around that task, around that part of the code that will be built out, right? So that is kind of how it works. You work with product management tools to create epics, create sprints, plan out your product development, product releases, products, the various features that you're building. Then after the coding phase, you go to the building phase. That is not confusing. The coding phase, you see, that's when you write your code, right? After you write your code, the various parts of your code, you now need to package it. You need to compile it, right? If you've worked with things like Java or C#, you know that after coding, Golang, you need to compile before you can release. Compile them into artifacts, whether it's a jar file, whether it's a bin file, a .py file. You have to compile the code that you've built. You compile it and then you have to test it. You have to test that the code is working. You have to test that there are no issues, there are no bugs in it. Who asked that question? So Luwani, this is where your QA guys come in, right? But we will talk more on that later. So you have to test the code. You have to test what you've built out. After testing it, then you go on to the stage of operating, right? In the operating phase, you take the thing that you've tested and then you release it into a live environment, which could be a dev environment, a staging environment, a production environment, or maybe after the production environment, a disaster recovery environment. If you don't understand what I just said now, that is very fine. You can do research, we will get to that as we go on in the course. So the code that you've compiled, you have to release it to users who can now make use of it, whether they're internal users or external users. Continuous deployment comes in here. In reality, when you work with DevOps, all these processes, you try to make them automated as possible, from your coding to your testing to your deployments, that is the releasing. Then the operations teams come in here and work with the code that has been deployed to operate it and make sure it's working as intended. You also have observability here, which includes all the monitoring, the logging, and the distributed tracing that we talked about, ensuring that your system is up and running. If there are issues, you can pinpoint them as quickly as possible. And then the continuous feedback, which involves, okay, how is the system performing? Things we need to change. It needs to open that line of communication between the DevOps team and the development team so that they can work together through this continuous feedback, so that the developers can know from the DevOps guys or the operations guys how the code is running with regards to the reliability, the uptime, the security, everything, and what changes they need to make if there be, and release them. So this process has to be automated and has to be continuous. Okay, finally, we are getting towards the end now. DevOps practices. Very quickly, if you have access to write on the screen, please do not write on the screen so that we are all together and we don't get confused. Okay, thank you. So DevOps practices, the various things that, and the various practices, the various methods, the various activities here that are involved in DevOps, various activities that you will usually do as a DevOps engineer, the things that you need to know about as a DevOps engineer. Continuous integration. Continuous integration can be best explained as like this. You have a product running, right? You have a product running and you need to make updates to that product. You need to be able to seamlessly integrate new code into code that is already running without breaking that code, without cooking beans, without introducing errors into that code. So as continuously, you need to integrate new changes, new features, fixes into live code that is into your, let me just say it, into your master, your main branch. You need to be able to include code into that. Your continuous delivery, you talk about now deploying code continuously into your environment seamlessly. So continuous integration, continuous delivery, they go together, integrating new code and deploying the code into your live environment. And this needs to be continuous. It needs to be error-free as much as possible. Infrastructure as code, that's another thing that is involved in DevOps. Instead of manually configuring your infrastructure, instead of manually configuring your servers, instead of manually configuring your cloud resources, you need to be able to manage your infrastructure using code. Why? One, to make it seamless, to make it easier, and two, to have a source of truth, to know what is running what was configured, even years later. Coming in to a team as a new engineer, you don't know what has been configured on the server. You don't know what has been deployed. But with infrastructure as a code, it is configuring infrastructure using code, using written code to configure your infrastructure. So somebody joining your team, joining your team can know what was implemented, what was deployed 5 years ago, because it is there as a source of truth in your code, right? This goes a step further into things like GitOps, which we can talk about later. You need to be able to have a sort of truth for your infrastructure, because this is a pain point for many teams where you have a server that is set up and everybody knows, do not touch this server, right? We don't know who set it up. We don't know how they set it up, but it is working. If you touch it and it breaks, you will be the one to find out what happened there and fix it. So things like that are things that we are trying to remove using infrastructure as a code. Microservice architectures. These can break down a product into various loosely coupled working services, right? If you have a product, say a food ordering system, right? You have your child deck, you have your Glovo. You can break down that software into various pieces of code. You have a service, right? A service, a code on its own, a product on its own, inside your entire product, right? For ordering, say your ordering service. You have your ordering service, you have your user management service that manages the login process, the login process, the sign-up process, and all of that as its own service. You have maybe your rating service. You have maybe, what other features can be in a food ordering?
Payment service.
Payment, excellent, thank you. You have your payment service on its own as well. Now, what this does is you can, since they are loosely coupled, there is fault tolerance. If there's an issue in your payment service, it's not affecting the ordering system, right? With microservice architecture, you can even outsource that payment service to a third party, right? Paystack can handle your payments for you, your payment system for you, while you just focus. So that microservice architecture is something that helps you when you're working with DevOps it improves reliability, it improves fault tolerance, it improves management of team, right? Automation. When we talk about automation, in my opinion, that is the heart of DevOps itself. That is me talking. No, I don't know. Automation is what makes everything beautiful. Automation is what is behind CI/CD. Automation is behind infrastructure as a code. Automation is behind monitoring because when you're doing monitoring and observability, when there's an alert that goes out, this thing is happening. You want to be able to set up automation so that the next time that alert comes up, whatever you did the first time to solve that issue, either doesn't happen again or it can automatically run those processes that you ran to solve that issue. This is where we start talking about Ansible and playbooks. So things like that is what makes automation, to me, the heart of DevOps. Automating processes, being able to write code, write scripts that can do things for you. When you come to things like site reliability engineering, there's something that's they say that is your goal is to automate yourself out of a job. If you're able to reach that level, hallelujah, thank God for you, where you automate yourself out of a job and you come to work to sit down and chew biscuits. That doesn't happen, but that is the goal, right? Then monitoring and observability. We've talked on this a lot. You need to know what is happening inside your software. You need to know what is going on. You can't be blind. You need to look at what is important and be able to pinpoint errors when they are occurring. Pinpoint abnormalities when they are occurring, right? An error might not have occurred, but the way things are going, an error would soon happen. Your CPU is being overutilized at a fast rate. Nothing has happened yet, but you know that if things keep going down this trajectory, there will be an issue. That is what monitoring and observability helps you to do. Okay, so that's that on DevOps practice. We're going to finally now touch on the DevOps roadmap. The things you need to learn when you're learning DevOps. You need to learn about operating systems. Operating systems, oh my, sorry about the numbering here. You need to learn about the operating system of various computers, various servers. You have Linux, you have Windows. Most of us already work with Windows from when we started using computers. You need to learn Linux as well, as most servers. Yes, most servers that you will interact with would usually run on Linux. Linux was built as an open source operating system, whereas Linux was built as an open source operating system, whereas Windows is more proprietary in how you need a license, to work with Windows. Hopefully, you don't want to crack your Windows. Don't do that. So, but with Linux, it is more open source. That's why you have various flavors. Various people can take up the source code of Linux and build their own Linux flavor from it. You have Fedora, you have CentOS Linux, you have Kali Linux for the hackers, you have Debian, you have Ubuntu, right? You have various flavors of Linux. You have some that are actually now proprietary, like Red Hat Linux. I don't think that is free. So you have various flavors of Linux. So you need to learn operating systems. You need to learn programming. Don't think it came into DevOps to run away from programming. It will jam you back. So you need to learn programming. You need to, because you'll be doing scripting. We are going to be touching on Python later in the course. You might need to learn Golang at some point, depending on the team you're working with. A lot of tools that are being built today in the DevOps space are built on Golang, Helm, Prometheus, Docker, things like that. You need to learn networking as well, because the internet, it's a system of networks. So you need to learn networking. You're not escaping programming, my brother. But it might not be as intense as a backend. It might be. It might be. You never know. You need to learn version control systems. That's where you talk about things like source code management, Git, things like that. That is involved in version control. Being able to have various people work from various places within the same code base, creating various branches, integrating it into your main branch, version control feeds into CI/CD, the CI/CD product process, right? Containerization, we'll get to that. Containerization, cloud computing, because a lot of products these days run on the cloud. The cloud has changed. The cloud has changed the pace of the game, because to build a product now, to build a software, I don't need to buy huge servers and keep in my garage, right? I can on demand buy what Microsoft is the resources that they are giving to me through Azure. I can pay on demand for AWS services, Google services. I can use Linode or DigitalOcean if I don't want to crack my brain too much, There are various cloud computing platforms that you can utilize. CI/CD, container orchestration, infrastructure as a code, monitoring and observability. So these are just some of the things that you need to know as foundations to starting out in DevOps. There are other things that advanced level, intermediate level that you need to know. But starting out, these are some 10 things that we can say are very essential to the DevOps practice. So that brings us to the point where we ask questions. We ask questions about what was taught. I think the first one we can take is from Temi Lolua. Okay. She on the call. Temi Tope. Okikolu.
Oh, Kikiolu, are you not Yoruba?
But no, well, I'm learning to speak. But first of all, I hope we all understood the class and learned a thing or two from what was taught.
Yes, thank you. So can I go on with my question again?
Yes, please. Yes.
Okay, so my question is, now I'm a QA engineer.
Okay.
So I have
You're a
so
QA
much,
engineer presently.
yeah.
Okay.
So I have so much interest in DevOps. At times, the product is into your hand. Sometimes you have to understand, and at some points you might have to match yourself. So times as a QA, you want to see the process of how some product or PR you have to test get to you. Or at times you might want to merge and test and not wait for developers and all that. So my question is, I've seen some of my people as a QA move to DevOps. I'm a kind of person that love to evolve with the current and latest technology that still has to do with what I do. So that is why I'm diving into DevOps. So I have done my research and I saw DevOps QA. So that lingers my question this evening, that can you explain more how I can interact or how DevOps interacts directly with QA? And if I say, okay, I'm learning DevOps right now, will I be able to practice as a DevOps QA engineer? Because in some job requirements, the request for AWS DevOps, you understand? And I'm just like, do we also have to do with all this? And that is why I'm asking this question.
Okay. Okay, thank you for that. So I brought us to this page so that I don't know if I have a pointer. I don't think so. Okay, so I brought us to this page because this is where I want to explain from. So when you talk about QA and when it comes in to DevOps, of course, the QA engineer works on testing the code, making sure that the code passes certain test cases. Now, traditionally, you can have communications with your developer one-on-one and write scripts, and he tests it. Maybe you run the scripts on his code manually using Postman, right? Selenium and all of that. I think you can see Selenium here as well in this picture, some of the tools here. So integrating the build process and the testing process into your CI/CD pipeline, right? You know that your environment for deployment is some cloud platform, AWS, Azure, or GCP, right? So you need to know how to interact with that environment as a QA engineer. You need to know how to write your test scripts and integrate them into a CI/CD pipeline that is being used by a team that you're working with. So these are some of the things that you need to know working within a DevOps team and a QA team. Because you spoke of a term DevOps QA. I've not heard of it before, but what I would assume that it is speaking to is the interaction between DevOps and QA, which would be in the build process, the testing, automated testing, integrating that into the CI/CD flow, the CI/CD pipeline, so that you can automatically build software, have it tested before delivering it into your live environment, or delivering it into your QA environment, because most times the QAs have their own environments where they can run tests on code, the staging environment before you deploy it into the live environment, where they can run tests, break down the code as they are known to do. Sorry about that. Break down the code, test it, and before delivering it into the live environment for customers to use. Right. So focusing on the CI/CD process is where the QA will usually come in. I think we have some questions in the chats. Okay, Latifa, I see that. Okay, does that answer your question, Temi?
Yes, you answer my question, but not you didn't really dive into it that much.
Okay.
Yeah.
There's something you want me to touch on specifically?
I'm just trying to maybe just because you're in DevOps, I'm just trying to find there is a way we clone from the development environment to the testing environment to test what we have to test based on code. We say that very first. So that's what I'm asking, but I understand, Sha, because most of those tools that is here, I have made use of them, and I think the same thing DevOps are using. So it's just that I would have to learn other things, other tools that are here. So with time, I will understand better. That's what I know.
Yes, I understand. So someone is asking a question about software engineers making good DevOps engineers. So like Temilolua is saying, coming from a QA field, or background, coming from a software engineering background, you've already had interactions with some of the tools that are used in DevOps. You already understand some of the practices and some of the concepts. So it might be relatively easier to pick up some things and understand them quicker. Like Temi will know about testing. She will know about having different environments for various things, dev environment, separation of concerns, dev environments, QA environment, and your live environment. Someone from a security background might know a lot about operating systems, Linux, application security, and things like that. But that shouldn't be a deterrent. That shouldn't be intimidating someone starting out as a newbie, right? With focus, you can pick up a lot of things from starting out in DevOps. It's not something that has to be done by someone coming from another field and having knowledge in certain things. People come from, medicine to come into tech, into DevOps. So you just need to be focused and resilient and ready to learn. Thank you for that question. Well, that's one is not for me. You say, I think it's it's a great idea to focus on one thing, especially when learning, to focus on one thing. We are going to be touching on the parts of Python that are most aligned to the things we need in DevOps, right? So there's no need for you to try to join any other class. You get everything you need specifically for the tracks that you've chosen right here. Of course, I would recommend doing your personal research, running your personal projects on your own, right? Because that will help you when you come into the class, you already have some things that you're carrying in your bag. Okay, so that is something that we should all try to do. I'll be giving some classworks, work on the class. I'll be giving some homeworks, right? Some assignments, work on the assignments, try to do them on your own. If you have a problem, try to do research to solve them. If you can't solve them on your own, people are available on the group, on the Discord channel. Ask your questions and you'll be attended to. Also try to do, if possible, if you have the time, if you have the bandwidth, also try to do your own personal studying, right? Of course, Latifa, please go ahead.
Good evening, sir. I wanted to ask about the learning management system stuff before we started the class. So nobody have been saying anything about it. So I don't know how they are supposed to track our activities and other things. Hope I'm not.
You were breaking up, sorry. You were breaking up, I didn't get that. Hello, Latifa.
Okay, I said that I wanted, sir, I'm here, sir. Can you hear me?
I can hear you, yeah.
Okay, I said I wanted to ask about the learning management system we talked about during the last class I attended, or should I say orientation program. So nobody is saying anything about it. So I just wanted to ask, are we still doing it, or is there another way of keeping track of our activities? And I don't know.
Okay, I think
I hope I'm making any sense.
oh yes, you're making sense. You're making sense. I think Imole or IK will be in the best position to answer that, to best answer the question. So perhaps they would address that. Okay, maybe she didn't hear you. I'll bring our attention to it. Maybe we will have to get back to you on that one. We have to get back to you on that one. But don't worry, your question will be answered. If it's not answered in this call, just drop it on the Discord channel again. Right, Latifa? If we are still using the LMS.
Yes, sir, I will. Miss Imola already asked to drop in the chat, so I will. Thank you.
Okay, Michael, please go ahead.
I'm sorry, my environment is currently kind of very noisy. So I just dropped the question in the chat. I was waiting for your response.
What's the question?
I'll paste it right now.
Sorry? Ask the question.
I dropped it in the chat previously, so
okay, I might not have seen it.
Yes.
Just ask the question again.
Yeah, sure.
Okay. Okay, it says based on the automation processes in DevOps, how is the job security like based on the constant rise in AI tools and services? Okay. Okay, you're asking if AI will take your jobs. AI is a tool, right? Has Kubernetes taking the jobs of infrastructure engineers? Has AWS taking the job of system engineers. I think AI will make your job easier for you, right? You have ChatGPT, you have Google Copilots, you have various LLM systems that are being used presently in DevOps. I worked in a team once where my manager we always say, how do we integrate AI into what we are doing? How do we use it to make our jobs better, make our jobs easier? So that is what AI will be doing for you. They'll be making your job better for you. Now, if you sit down and you decide not to pick up these innovative changes that are coming, if you try to stand in the way, you are not learning how to integrate AI and machine learning tools into your workflow, you don't want to work with anything AI because, you want to remain old-fashioned, then of course it's possible. Like, these things are trends. They are trends. When the internet came out, there are some people that did not believe in it, did not want to work with it, and they probably either drown. The innovate or die, basically. That's all I can say. You have to work with the innovations. They are coming. So they are not taking your jobs, except you decide not to innovate. Okay. Thank you, Wogo. I'm looking to 7:30. There are some tools that we need to install. So I'm trying to see if we will have time for that. Before joining DevOps, I saw that there's like categories in DevOps as if one could specialize in an aspect and not be a DevOps engineer. Please, how true is this? Can I just be in the networking aspect and all? This depends on the team that you're working with. This depends on the team that you're working with. This depends on the project that you're working with. There are some teams where, as a DevOps engineer, you'll be more involved in infrastructure stuff. There are some teams where you'll be more involved in reliability, site reliability engineering. So when you talk of DevOps, you hear of things like DevOps engineer, site reliability engineer, platform engineer. So this it depends on the kind of team you're working with, right? If you want to specialize in networking, don't throw away monitoring, right? Don't throw away operating systems. So you can learn, and it's best you learn as much as possible. I'm not against specialization, but it's good to know as much of everything as you can, right? If you get into a team where you are known as the networking guy, anything networking that you don't understand, go and meet Damilare. Go and meet Damilola, sorry. That's great as well, but it's good to know a bit of everything. Okay. Okay. Welcome, Michael. I think I answered the question, I hope. On the Discord channel. Yeah. Most of the assessments will be dropped on the Discord channel. Okay, let me reshare my screen so that we can see how far we can get into. Are we all with our laptops, first of all?
Yes, sir.
Okay.
Yes, we are. We are here. We are
On my-
on my side too.
How many of us, by the show of hands, have Visual Studio Code, VS Code on our computers?
I have.
I do have.
Okay, let's do it another way. How many people don't have Visual Studio? Raise your hand if you don't have it. If you have it, put down your hand. Oh. If you don't have it, I'm saying Magnus, Latifa, you have it now.
No, sir, I don't.
Oh, you don't have VS Code. Okay. I think that's where we should start from. Hold on a moment. We are at 7:26. That means we have about 34 minutes, I guess. Let's see what we can do in that time. Imole, are we done? Should I stop the recording? Because I'm about to go into installations and things like that. Setting up the environment. Okay. So just give me a moment. I'm trying to get something. While I'm trying to get something, can someone just give me, a quick rundown of what you learned? I'll start with the people that already have their hands up. Magnus. Who can give me something? Tell me what you learned today, something interesting that you learned today in particular. Latifa, just one thing.
Sir.
One thing very interesting you learned today, something new you learned today. Just one. I know you mentioned everything, but just one thing. Okay.
Well, let me give it a shot.
Okay, let's go.
We started with software development lifecycle, what it's all about.
Okay.
And you made us understand that it refers to a structure or framework that is used to design, build, and test quality software products. And then you went down to the SDLC models. You mentioned waterfall, Agile, Rapid, V model, and others. And your core area of interest was more of the Agile SDLC because of the flexibility it brings to the table. And then after that, I think we talked about, let me check my notes. What I also got here, the 8 DevOps phases: the planning, the code, build, test, deploy, operate, observe, and the continuous feedback about it. Then what I picked up again was the DevOps roadmap, where basically these are the things that we should learn. I got scared when I saw program there, but that notwithstanding, programming is there, networking is there, containerization is there, and CI/CD and others. So that's just basically it. That's aside that, everything is very, very clear to me.
Thank you. That was wonderful. That was wonderful. You really were part of the class. I said one thing and you said you basically gave a full summary.
Oh, thank you, sir.
That's fine, Latifa. It's not a problem. It's okay. So some people have their hand up. I don't know. Do you want to ask something or it's a mistake? Magnus. Okay. It was a mistake. Magnus, your hand is up.
So you told us to raise our hand, not have VS Code.
Okay.
Yes.
Okay, these are the people that don't have VS Code.
Yes.
Okay, if we can check in the chats. I've dropped 4 things that we need to install. Today is Friday, so we have to install this before the next class. I'll try to cover as much as possible. So we are going to start with VS Code, right? I have VS Code already, which I got on my laptop many weeks ago or months even. But I'm going to try to see if I can walk through the steps of installing it for those that don't have it. Right. So can we see my screen? Magnus, can you see my screen?
Yes, I can. I can see your screen.
Okay. So
Yeah.
Latifa, you with me as well?
Yes, I am.
Okay. So I'm going to get this link for us. And you can easily just go to the link and download it based on your operating system. That is for VS Code.
Okay, so please, I want to ask you a question. Can I download it directly from Microsoft Store?
You don't want to download it from the internet? You have some reservations with that?
No, I don't.
Huh?
No, I don't.
Okay, I will advise you you can download it from Microsoft Store. You should just probably just download it from the website. It will probably be easier.
All right, sir. All right.
Okay. Latifa, how are things on your end?
It's going well, sir.
Okay. So we are going to be working a lot with the command line, right? So for that, it will be good for us to get Git on our systems so that we can interact with the Git CLI. Hello, Chris. Chris, I see your question. I'll have to say no. I'll have to say no to that because it will be difficult for you to interact with. I'm trying to use Visual Studio. No, I don't think it can. First of all, from what we see here on the page, you see that you can do the things that are provided, the operating systems that are provided, Windows, Linux, and Mac. So those are the 3 operating systems that you can download your Visual Studio Code on. Trying to code with your smartphone, it might be good for learning purposes, but you probably shouldn't be doing that. Okay, so I'm dropping the link for downloading Git. On your terminal, do Git version and see what it says. That is for news. Do something like
Oh, guys, news, not news.
my boss, no vex for me, Biko. News say. Is that your that's not Yoruba? Is that Delta?
No, it's Akwa Ibom, please.
Okay, okay.
You said I should do what, please? Git what?
Git version.
Okay.
Let me just write it. On your terminal, just write Git version. Then tell me what it says. Yes.
Okay,
Martha, we'll be following. What did you see?
Git version 2.45.0.
Say that again. 2.5 what?
2.45.0.
Okay. So you have Git. You have Git installed. You also have VS Code.
Yes, I do, sir.
Okay. So Luani. Okay. Yes, exactly. That question is for Emole. We are following the curriculum, yeah. What did I say will be after Git?
Please, I asked a question, sir. Good evening.
Okay. Who is speaking?
Yeah, this is Nicholas.
It's who? Nicholas.
Nicholas, yeah.
Okay.
Okay, so I've not on the Discord channel, so I was asking, you said you are going to be dropping assignments on the Discord channel. So I don't know how I could be maybe added to the channel or something.
Okay, I think Imole will take care of that.
Okay, thank you.
Okay.
So she's going to contact me, or I should contact her.
You contact her.
Okay, fine. Thank you.
You're welcome. Okay, so the people that were installing VS Code, are we done?
Still on it.
Okay.
So I'm done downloading mine. I'm trying to install it now.
Okay. Adedeji.
Good evening, sir. Please,
Good evening.
I'm trying to download the JIT app, and it's saying there are two types: standalone installer and thumb drive edition. Which one should I go for?
What are the two types you're saying, please?
Standalone installer and portable. That's thumb drive edition.
This is on Windows.
So
Yes, Windows 10
Try
60%.
standalone installer.
Okay, thank you.
Okay. Who was speaking? Imole, was that you?
no, sir, it was me. Sorry.
Sorry, before you speak, let me quickly address some things. The first thing, if you are not called, please don't unmute your mic. Please, these videos will be uploaded on YouTube, and if it is rowdy, if you are the one listening to it, you won't like it. Please, let's maintain coordination. And if you are not called, don't unmute. If you want to speak, raise your hand. Don't just unmute and go ahead and speak. Also, the second thing is the person that talked about not being on the Discord channel. I'm trying to communicate to you via the chat. Please, I'm waiting for you via the chat. Thank you. You can go ahead.
Okay. Latifa. Yes, Latifa. Go on.
No, I was having an issue, but I've been able to resolve it. Sorry,
Okay.
sir.
Yes, that's excellent. That's excellent. Emmanuel.
My question is concerning what you outlined that we're going to install. I saw Git there, I saw VS Code, but my question is, why are we installing Vagrant when we have VirtualBox?
You have VirtualBox on your system?
I have VMware, I have VirtualBox.
Okay, you're asking why you need
Vagrant, yes.
Vagrant provides a way for you to seamlessly run and start up various operating systems, various packaged operating systems. Whereas if you have just VMware or you have just VirtualBox, you might need to go out on your own to get the ISO. That is to get the image.
Yes, and install.
Right? If you have with your VirtualBox, you would usually download a Linux image from the internet to run. That's the process you use.
Okay, but Vagrant is already packaged software. You just have to on and off.
Yes, exactly. You can just do Vagrant up Ubuntu, and it will get the Ubuntu image for you and start it up on VirtualBox.
Okay.
Yeah.
I think I've not worked with Vagrant much like that, but I've worked with VMware for some project and also VirtualBox too. But it's a nice thing. I would like to try the Vagrant too.
I just want to say this now. People that have experience with various tools, you would be helping other people inside this, because when I started, I said we are all DevOps engineers here, I knew that there will be people that, in fact, we have a QA engineer here. I'm sure we have a lot of backend engineers. We have a lot of, so people saying, this coding thing, don't worry. You'll soon find out there are some people here that are backend engineers. There are some people here that might be security engineers. So this our brother now, he will be helping us a lot with our virtual box. Isn't that right, Emmanuel?
Oh, well, we're switching to Vagrant now.
Thank you. You said you would now.
No problem.
Yes, thank you. So we'll be collaborating a lot in this our little community. Okay, Magnus, go ahead.
All right, so I'm done downloading and installing VS Code. I wanted to ask if I can continue with the installation for Git.
You're done with VS Code.
Yes, sir.
Okay, let's go ahead. Go ahead with Git.
Okay, but there are some options that are here for me to choose, like
Okay.
choosing SSH table and all of
Say
that.
yeah.
Should I just? I said there are some options that are showing here for me to choose, like choosing the SSH executable. I'm seeing two different options, but I don't know which one to choose.
Did you say SSH?
Yes, yes.
Choosing the SSH.
Yes, SSH executable. That's they say which secure shell client program would you like Git to use? So there are two options: use bundle open SSH or use external open SSH. I don't know what it means. I don't know what to choose.
This is when you're trying to install what? Git.
Git, yes, Git.
Okay. One moment. Let's hear from Imola, then maybe you share your screen. You know how to share your screen?
Yes, I know how to share that.
Okay.
No problem.
Imola,
Yes, I'm here.
your hand is up.
Oh, so sorry. I
Okay.
must have
Okay.
forwarded before. Why?
Okay. Magnus, please, your screen. Latifa, how are we doing?
Sorry,
It's going well, so I've just my network is low, so it's
You're able to what?
I said my network is a bit slow, so it's taking time to download, but they are
Okay.
actually downloading.
Okay.
Still in progress.
Okay. Okay, Magnus, please go ahead.
Okay, so you disabled the participants sharing their screens.
Oh. Okay, we will have needed the IK for that. Okay, could you just explain better what you're saying?
Okay, when I tried installing Git, there were some options that were some options that were given to me to choose from. So from the beginning, I've just been choosing the ones that like the default options. So I don't know if that will affect me. Part of it was this choosing the SSH executable. So I don't know if I should just choose the default option. I hope it won't affect me.
What does the default say?
The default says use bundle open SSH.
What's the other option?
Use external open SSH.
Bundle open SSH.
Yes.
I think you go with
the
that.
second is external open SSH.
External.
Yeah.
Go with the bundle one. That is the default.
Okay. Yes, that's the default.
I think the external might need you to set up open SSH on your own or something.
Okay.
So just go with that default one.
All right, sir. Thank you.
Okay. All right. So if we are all at the same page, we all have Git now. Latifa, don't worry. Don't worry. We will still align before Tuesday. So we all have Git installed. Someone's hand is up. Please go ahead.
So please, what's the difference between Git and GitHub? Is it the same thing?
Say that again.
The difference between Git and GitHub.
Okay.
Is there any difference?
GitHub is a source code management tool. It's where your repositories will sit, right? It has a GUI interface. It works with Git. There are various tools that work with Git as version control. You have GitLab, you have Bitbucket, you have GitHub. So GitHub is one of the tools for version control that work with Git. Now, this Git that you're downloading now is for your CLI commands. Without it, you can't interact with Git using your CLI. GitHub, on the other hand, is just a tool that's you can use this same Git for Bitbucket, you can use it for GitLab, you can use it for whatever source code management tool that you choose, right? Because they all work with Git. But GitHub itself.
Thank you.
Yeah. Nicholas.
Yeah, okay. I'm asking, I've tried to download the Git of my network, and it's showing 32 bits, 64 bits. So I wouldn't know which one to choose.
Okay, hold on.
And I've also downloaded the VCRB, what's the name? The VS Code. I've also downloaded the VS Code.
You didn't have VS Code before?
No, I didn't. I just downloaded it now.
Okay, so I'll drop something in the chat for you.
Okay.
Okay. I wouldn't answer the question. This is just to help you, just develop the mindset of carrying out research. Right. So
okay, fine.
I think you can just go to this link. Right. And that will just help you answer the question. Okay, so thank God. Okay, Nicholas. Thank God.
Sorry, I didn't realize my hand was still up, but I wanted to help the guy that asked the difference between Git and GitHub.
Okay.
So I don't know if you got the answer or I should still go ahead and.
Oh, go ahead. Yeah, go ahead.
Okay, so Git.
Oh no. Hello.
Hi.
GitHub is Git itself that helps you keep it's a version control software, of course, that helps you keep track of different versions of your work, your software. So say you make a change and you want to lock in that change to your product, then you can make a commit on Git. So Git is the one you install to your local system, your PC, to manage that software. While GitHub is Git, but hosted on a cloud platform. So the same way you use Git on your system, when you are done working on your local environment and you want to push it to, like a public, like a public place where other collaborators can see what you've done or contribute to it, that's when you now use GitHub, because it's hosted on the cloud and someone else can have direct access to it, of course, with permissions. to collaborate on that project. So that's what I wanted to say.
Sorry, please.
Thank you, Tangod.
So please, I have something to.
A follow-up. Yeah, go ahead.
So the thing is, so you mean GitHub is cloud, why Git is local? Nobody else can see what I do on Git, but I can share what I have on GitHub.
It's kind of, yes. It's like you're installing it on your local system now. You get, so it's going to run on your system, the system you're installing it on. If you're going to use another system, you have to install it on that system too. But for GitHub, you have an account on GitHub, right? So whatever you do on GitHub, you can easily send somebody a link. Say maybe you develop a software and you want, or maybe a package, and you want somebody to contribute to it. You can send somebody that link or the project on GitHub, and the person can now fork that project and be able to make modifications to it, that kind of a thing. So Git is on your system, is on your local machine. Why GitHub is a cloud platform. It's not Git itself, it's a cloud platform that is hosting Git that can help you collaborate with other developers.
All right. Thank you very much. Thank you. Thank you, Coach.
Okay. So we wouldn't be able to do the installation of Vagrant today because our time is almost up. But we've been able to get, I think most people have been able to get VS Code and Git on their system. What I'll do is within the week on the Discord channel, I'll be dropping some tutorials that we can, of course, some tutorials that we can use to download it on our own, right? Both for the VirtualBox and for Vagrant. I'll also drop the link on the Discord channel. And I'll send some videos too, so that we can watch the videos. And I'll look for one that's as descriptive enough so that we can watch the videos and download it on our own, right? So, Michael, big ups, Michael. Well done. So, Michael has downloaded it and installed it by himself. That means everybody can download it and install it by themselves. That's what that means. So, we're going to have to get it installed before the next class. I think, let me see. I think that will be our assignments. Okay, I'll send another assignment too, which will just be, for you to, you'll see the assignments. It will basically be for you to, come up with your own, do your own research and come up with your own paper on SDLC. Martha, your system runs on Ubuntu. Yes. Yes, download Vagrant. Download Vagrant. Okay, where is your Ubuntu? Where is your Ubuntu? Where is your Ubuntu, Martha? Is it on VirtualBox or something? Okay, well, anyway, you still download Vagrant so that you can follow with the class. Yeah. I think that is it. Check in with us, Latifa. What's up?
I'm following, and I've been able to install the VS Code. If I'm correct. So I'm still downloading the GitHub. Still in progress.
Okay, so I'll drop a list of all the things we need to download on Discord, because this chat is not long-lived. So I'll drop it on Discord and we can always see it. I'll drop the links as well. I'll drop a video on Vagrant. So that's my assignment. Your assignment will just be to download it for now. And the other assignment that I'll drop within the week. So this was a very interactive class. I like that. Let's keep it up. Thank you so much for joining. We got to 40 at some point. But some people have dropped off and we are now 34, 35. Someone just joined. So thank you so much, everybody, for joining. It was a class 6 to 8. And welcome to the DevOps journey.
Thank you, sir.
Thank God, what is your background? Like, are you from a tech background?
Yeah, I do full stack.
Sorry?
I'm a full stack developer.
Okay, there we go. Who was the person that said I was just whining you people? You can see now.
Now wow.
You dey see him?
Only me waka come o.
Abeg, carry me for back, abeg.
No problem. We're here to help each other. I'm always ready to help. If you have any issues, you can hit me up.
Thank you, thank God.
Thank you, Chief.
Okay, thank you so much, everyone, for joining. Imagine going into some other space later and saying that your background in tech started from a DevOps background. Just imagine that, princess. So that will be you in a few months. You'll be telling people that you got into tech with DevOps. Of course, definitely. You can get into tech from DevOps. Okay, so thank you, everyone. This was amazing. I hope to see you in the next class. This might be
When is the next
one
class?
of the only. That would be on.
When is the next class?
That would be on Tuesday. We have Tuesdays and Fridays. Please don't join with your name next time so that we can know who is speaking. It says Zoom user. Like I was saying, this would be, yeah. This would be one of the only theoretical classes we might have, right? We are trying to be as hands-on as possible. So let's be expecting that. Okay, thank you so much, everyone.
Hello, sir. Can we get the slides for this class?
We'll speak more on that on the Discord.